Commercial Drones FM is brought to you by FLIR Delta. Love listening to podcasts while commuting? Then be sure to check out the podcast from the world leader in thermal technology, FLIR Delta. Tune in for tips, tricks, and best practices for using thermal cameras with drones. Visit FLIR.com/Delta and download the latest podcasts today. Welcome to CommercialDrones.fm, the podcast that explores the commercial drone industry, the people who power it, and the concepts that drive it. I'm your host, Ian Smith. How much is your time worth? What if you could shave off minutes, maybe even an hour, every single day from each side of your commute? You could spend more time with family, friends, even being more productive at work. But what is the actual value of your time? It's pretty difficult to put an exact number on the cost of each second, but this is the question that Bell Helicopter wants us to start asking ourselves.
We want you to start thinking about valuing your time. I spend an hour each way in my commute to work every morning, and I have 2 daughters, and I'd rather spend those hours with them. And so when I think about what time is worth to me, in that scenario, it's close to priceless, but we'll work out the economics and see what it really means to you as an alternative to a car and bring it to you on a universal access basis.
All right, yeah, that's pretty vague. So what are we talking about here? Well, the future of aviation, for one. I'm at CES 2019 in Las Vegas and stopped by the Bell booth for some Q&A on their newest eVTOL aircraft called Nexus. Bell is part of Textron, a publicly traded company, and is one of the largest aircraft manufacturers on the planet.
Can you say that again, actually?
Yes, my name is Scott Drennan. I'm the Vice President of Innovation at Bell.
Perfect. Okay.
That's Scott. He's been giving a presentation at the Bell booth, focused on Nexus. Nexus could be described as many things: flying car, air taxi, passenger drone, or if you're being technically correct, an eVTOL aircraft. What used to always be computer-generated concept imagery of these contraptions when I'd see pictures of them on the internet had suddenly transformed into the real thing. Right in front of me at the Bell booth at CES stood Nexus, a vehicle that could very likely be the precursor to the future of aviation.
So, tell us a little bit, what are we looking at here? What is this?
Yeah, this is the Bell Nexus. It's the cornerstone of Bell's approach to on-demand mobility. And to us, on-demand mobility means moving people and also things from point A to point B in an on-demand fashion. Call it up, use it as an air taxi. Bring it to your distribution center, use it as a shipping means to bring efficiency and cost effectiveness to your business.
Anyone interested in aviation, the future of it, or the future in general, will also be interested in the specs of this thing. Let's get into the nitty-gritty here for a moment while I describe this vehicle to you. Nexus is a hulking, shiny, black eVTOL hexacopter aircraft with ducted fan propulsion and a 4+1 internal configuration, meaning it has the capability to carry 4 passengers and 1 pilot up front at the controls in the cockpit. It has a gross payload weight capacity of 600 pounds, and let's assume that payload is humans, because the interior looks very much like a high-end automobile, not that of a traditional helicopter. I mean, it even has cup holders. And backing up for a second on some terminology, the term eVTOL literally translates into electric vertical takeoff and landing. Emphasis here on the E, which is the designator for electric. So what's interesting is that this isn't planned to be a fully electric aircraft to start. Nexus will initially be a gas-electric hybrid. It has a mechanical thermal turboshaft which drives a generator that produces high-voltage electricity, which is then distributed out to the electric motors in each of the 6 motor hubs. Bell chose this hybrid electric propulsion system rather than going full-blown electric, so Nexus can fly further and carry more weight. The plan is to eventually get to full electric once technology allows. And also of note is the presence of said pilot. There will initially be a real live human pilot at the controls. This is due to regulations, safety, and probably to put the very first passengers much more at ease when hopping in.
This is going to be an aircraft, but is it optionally piloted? Is it piloted at first and then it'll switch and transition to more fully autonomous?
Yeah, sure. So we call this configuration 4+1. Normally when you tell people about how many people are inside, you would just say 5, and they would naturally think about the pilot. We say 4+1 because the +1 represents what we think initially will be a pilot because of customer acceptance, not so much because of the technology. And then as customers get more comfortable and we fly more data points with the pilot, who will be a safety and mission officer at that point on board, we'll transition to an autonomous configuration and add another person to the mix.
The fuselage of Nexus is made of graphite epoxy composite. Bell's design of this aircraft is striking. It's sleek, futuristic, and has thin strips of blue LEDs that evoke images of Tron. Bell, besides being one of the world's largest helicopter manufacturers, is uniquely qualified to build something like Nexus. They're the makers of the V-22 Osprey, a military transport aircraft that's also VTOL, which went through extensive development in the 80s and 90s. The V-22 wasn't without its own challenges, however. A series of fatal crashes over the years led to tumultuous times for the project, but it is still in service today. No doubt Bell will apply many of the learnings from the V-22 to the design of Nexus. This does underscore, though, how safety is one of the hottest topics for our flying taxi future. Because this and other eVTOL aircraft will be so heavy and due to the smaller size of their rotor blades, it's unlikely that Nexus and others can auto-rotate in the event of an engine failure. Auto-rotation is an aerodynamic phenomenon that your standard run-of-the-mill helicopters use as a safety mechanism in the event of engine failure. So on eVTOL platforms, there usually are multiple motors for redundancy. But a key differentiator with this type of aircraft versus more of the standard single-rotor helicopter is that in case of an engine failure, the typical helicopter, due to its design and size of its rotor disc, can actually glide along and land safely in a controlled manner by using the inertial energy that is stored in the main rotor from when the engine was powering it. Most eVTOL aircraft designs do not accommodate auto-rotation. So, I imagine that A, this aircraft will never crash due to motor failure, I hope, or B, there will be some type of system, perhaps a parachute, that will help save lives in this unfortunate scenario. I actually wasn't able to ask Scott about this, so I'm hoping to follow up and learn more about it a bit later on. There are going to be plenty of smart systems and intelligence on the Nexus to keep it safe, though. Sense and avoid systems, vehicle management computers, which tell the system where to go, flight control computers, which tell the system how to go there, and of course, plenty of other avionics. So now for the fun part, imagining myself taking this puppy for a spin. As a passenger, of course. I live in San Francisco, and one of the big commutes that happen for business around these parts is from San Jose in the south up to San Francisco in the north. It's a 48-mile one-way trek on land. Doing this commute by car at 8:30 a.m. on a Tuesday can take up to 2 hours. In public transit on the train, it's nearly the same. By air, as the crow flies, the route is admittedly a bit shorter, 42 miles straight over the bay, but I'm willing to bet that by air it's significantly faster, and we won't care in the end at all anyways.
And so just for like practical use case, I mean, what kind of range endurance are we talking here? You know, just as like a general consumer that could be a passenger in one of these vehicles in the future, how far can I get, or how long will it take me to get there?
In the Bell Nexus, we're targeting 150 miles at a cruise speed of 150 miles per hour. With the hybrid electric propulsion system, you can extend your range above and beyond what an all-electric vehicle can do. And so, yeah, that's probably more than most people do on their daily commute, but we also want to make sure that we can start thinking about reaching other cities, thinking about reaching rural areas, and then when the battery densities, energy densities, and power densities get better, we'll swap out the hybrid electric for an all-electric system. The architecture already allows us to fly all-electrically on our battery and energy storage system from EPS, and so we'll be ready for that all-electric future as well.
So by my calculations, that same distance and commute that would take me 2 hours in a car could take me just 17 minutes in Nexus. Compared to the 120 minutes from before in the car or the train, that's a savings of 103 minutes, more than an hour and a half. I'd be shaving off 85% of my commute time. There and back in Nexus would only be about 40 minutes of total commute time, and I'm buffering in a little bit of a buffer zone here. Let me put it this way, actually. I could take Nexus on 3 round trips between the 2 cities before I even complete one leg of my journey normally during rush hour. WTF. Why haven't we been doing this already? It actually reminds me of a legendary aviation pioneer by the name of Frank Robinson, who started Robinson helicopters, these machines that I used to fly. Frank's dream was to give the world an affordable helicopter that people could use as their own personal form of transportation in cities to get to work, for leisure, etc. He did a pretty good job, but unfortunately the things are still $250,000 brand new, way too noisy, and just not practical for that purpose at all. This new wave of quieter, efficient, and hopefully cost-effective aircraft can change the way we move around urban landscapes drastically. Okay, so when can we start flying around in futuristic taxis like Nexus? The answer to that, after the break. Today's episode is brought to you by kittyhawk.io, the enterprise solution for drone operations management, available on the web, iOS, Android, and DJI's Crystal Sky. Operating a successful commercial drone program doesn't have to involve a ton of tools and time making them talk to each other. With Kitty Hawk, you can manage your aircraft, operators, and airspace all from a single unified platform. Managers can use Kitty Hawk to monitor their fleet, assign missions, and effortlessly track compliance. Your pilots fly in the Kitty Hawk app with safety and compliance settings that you customize based on your company's needs. There's even an API to make integrating Kitty Hawk into your workflows easy and automatic. Visit kittyhawk.io to learn more. Skywatch.ai is a leading drone safety and insurance solution, providing inclusive, flexible, and affordable coverage for commercial drone pilots, from single operators to enterprise users. Protect your business, drone, and equipment by obtaining Skywatch AI's liability and physical damage coverage, either with an hourly or a monthly plan. Skywatch AI's hourly plan allows you to get insurance on the spot for a specific job at an affordable price. The monthly plan lets you fly with peace of mind, with complete liability and physical damage coverage that you can change as needed. Additionally, as a safe pilot, you can save up to 50% on your premiums just by flying safely over time. Download the Skywatch.ai app through the App Store, Google Play, and the Drone Deploy app market, and get drone insurance that's tailored to your needs. Okay, back to the show. No matter what, I needed to ask this question, and I knew Scott would of course already have meticulously prepped answers from his PR team anyways. But hearing it from him and imagining when we'll see these things buzzing around overhead was irresistible. When can we actually get into this thing and fly?
Nice. And what's kind of like the timeline here? Have you guys started test flights? I mean, I'm imagining, you do something at a smaller scale, perhaps. I haven't been around. I saw there might be like a small unmanned system hanging on the wall over there. But yeah, what's the timeline here, realistically for a consumer, and what you guys are kind of working on internally to get everything ready for launching this?
Yeah, so the Bell Nexus and systems like it we believe will be ready in the mid-2020s as a commercially certified, viable option for all of us to use. In the meantime, now to then, we're inside of our normal product development cycle where we do full-scale testing, subscale testing, as well as system-level testing and all aircraft level testing. That's kind of a normal process that we do as we develop vehicles, and I'm not disclosing any of the time periods there, but as you can imagine, between now and 2025, there's not a lot of time, so we'll be knocking those off in order to get ready for certification and production.
Repeatedly throughout Scott's presentation and while we chatted, he would name drop many of the large number of partners that work on Nexus to make it a reality. I was curious if this was normal or if it was special due to the uniqueness of this project.
You mentioned a bunch of partners earlier. So Uber's obviously one. Thales, Safran makes the engines.
Yeah.
How many other? I mean, are there a lot of like? It kind of reminds me of like Airbus, for example. I mean, they have so many different countries and different groups working on their aircraft, and I'm sure Bell does as well when you're developing other aircraft. But yeah, is this normal? Is this abnormal? Where there's so many kind of companies involved?
It's pretty normal. The number that we're talking about, we've just named, our 5 prime partners. What's not normal about it is the way we work together. We have stopped doing this business of we're the prime, you're the sub, you're my vendor, I'm the vehicle operator. We are truly a team. So all of the smart people working on the propulsion system can tell me what they think about the airframe. All the smart people working on the battery system can tell Safran about the engine system or the integration. These are systems of systems, and if they don't integrate right, then it won't work. And when I take that kind of image in my mind from the integration of the machine, I translate it to my team. So the intellects that we have on all of those teams, if they're not integrated, then we won't have an integrated system and we won't succeed. That's what's different about it.
And just a little bit on the.
But to me, the most thought-provoking partner of them all is Uber. As you may know, Uber has been speaking about their own Elevate initiative for a couple of years now and have even had 2 conferences about it. One most recently in LA and the first in Dallas, just a stone's throw from Bell Helicopter's HQ in Fort Worth. Uber's core product is moving people around, but they're expanding into food and other avenues as well. They're laser focused on innovating in mobility. Uber describes Elevate as the future of urban mobility, so they're likely to look at starting early in the sky with drone deliveries through Uber Eats, where they already participate in the UAS IPP. Uber Elevate has very much been the vocal proponent of placing eVTOL technology in our lives, and their initiative also encompasses a litany of partners, Bell among them, to develop the aircraft, components, batteries, concepts, and systems that will make these dreams a reality.
And you guys are definitely like well publicized and partnered with Uber. In the event that Uber wasn't so, I guess, gung-ho, as it were, for this, is this something that Bell would be pursuing regardless?
Absolutely. We are looking at a broad customer set, one that includes Uber and their mission, but it can include all kinds of other missions in that same space, or in the logistics space, or even if the military customers wanted it as well.
In order to hit the 2025 goal, there are no shortage of challenges to overcome. My observations from the drone industry are that even though regulatory hurdles may seem insurmountable, the technical side has always outpaced the bureaucratic shortcomings and delays.
And just a little bit on the challenges. I mean, obviously there's regulatory challenges. I asked the question while you were on stage. I mean, do you think, because, to me, coming from, mainly the drone industry and also just traditional manned aviation, the technology is kind of already there. Like, it's totally fine. Like, you could really probably feel very comfortable sending this autonomous with passengers without incident. I mean, but what do you think are like the challenges? Are they more regulatory than kind of technological challenges?
Yeah, and thank you for asking that question. Technology is always really fun to talk about, but when you stack it up against the things that we have to do, we put it at the bottom as far as the biggest challenges that are out there. Sure, there are lots with that, but my team will take care of that. We talk about operational, certification, manufacturing, and technology frameworks. And there's challenges in all those first 3 that oftentimes companies that aren't aware of how to get a vehicle like this into certification and production, they kind of forget about it. And so operationally, how do we interface with the airspace and the infrastructure on the ground? Regulatory. We have to certify this vehicle with the regulatory bodies. We have a regulatory body inside of Bell itself, and we work with the FAA every day. And then manufacturing, it's so capital intensive to build a factory, you better have that with you now, which we do. Now, it doesn't do these vehicles yet, but you can imagine how that factory can transform itself into a factory of the future that can serve this need. So in the order of things, operational, regulatory, manufacturing, then technology in our minds.
If you couldn't already tell, I'm extremely excited about this technology. For me, personally, it's at the intersection of two of my most beloved passions, drones and manned aviation. Moving people and things around efficiently and at scale. Drones are absolutely paving the way for the network of flying cars and air taxis that we'll soon have. The disruptive technology planted a proverbial stake in the ground for regulators and the world's population of what is possible. eVTOL aircraft like Nexus are just big drones with seats in them. In any scenario I play out in my head, there is literally no possible way that autonomous electric aviation won't happen. The pieces are all there, it's just a matter of when.
Everybody has it. Existence is love.
Look forward to more podcast episodes about urban aviation, eVTOL, and air taxis as time crawls on. It was a pleasure having you here.
Cool. And the last question is like, what really personally excites you about this? You know, like Bell aside, just you as like a human. I mean, are you a pilot yourself as well?
So thank you for that question too. I'm an aerospace engineer.
Okay.
When I was dreaming as a kid to be an aerospace engineer and create things like this, I never even could imagine that we would have gotten to this point. I don't do a ton of engineering anymore. I'm leading an engineering team. So that dreaming translated into me working many years as an engineer when I started with Bell, and now it's transformed into me guiding great engineers. That's where my thrill is. I am so proud of my team for what they've done here. We have beautiful young minds, seasoned engineers. They're all working together on this tough challenge, and I'm just kind of putting up guardrails, knocking down obstacles, and when I see them achieve what they've achieved today, I can stand tall and be really proud of that.
Well, it sounds great, looks great. Very excited to be a passenger on one of these. Maybe I'll fly one whenever we have the optionally piloted.
You know where we are.
Yeah. But thank you so much for being a guest on the podcast today.
Thanks.
If you explore what you love when you say you love yourself, you will make the startling discovery that everything you love is something which you thought was other.
Commercial Drones FM is supported by MicaSense. MicaSense develops drone-based sensors for agriculture. With hundreds of research publications, dozens of case studies, and customers in over 75 countries, MicaSense sensors are proven to increase yield and save your customers money. For more information on what a MicaSense sensor can help you achieve, visit micasense.com.